Hello and welcome to this video accompanying the Choose Your Own Adventure assignment in Stats 391. This Choose Your Own Adventure actually counts for two of your 5 spots, required spots to get full credit for all Choose Your Own Adventures. It's a little more intensive. For one, you have to sit through this video to finish it out. And it's wanted to provide a little incentive for going a little bit above and beyond the course. You won't have to do a lot of coding in this one. Most of the code is given to you already. You just have to follow along with the notebook. I won't go into detail in all the code that I've typed out, but it is going to give you kind of an overview of some of the powerful tools that you can use for data analysis workflows that we weren't able to cover in this class. A couple of objectives in this activity. We're going to be working with a unique data set. So we've already worked with a plant data set in class that we grew ourselves. We also worked with a very large data set that was available, open source data set available through the National Health and Nutrition Survey, examination survey. In this data set, we're going to be looking at the Sustainable Development Goals that were set by the United Nations. There's a very large data set. But we're going to run into a couple of issues when working with that data set. One is we may not be able to answer the questions that we'd like to with the data available. We may need to go look at additional data sets. We need to figure out how we can combine data sets. That's a common problem in data analysis. Another thing that we weren't fully able to cover in class just because we didn't have time was the power of data visualizations, the kinds of questions that we can answer using data visualizations and the tools that we can use to create creative and unique data visualizations that go beyond a normal scatter plot or a bar chart. That's kind of the outlook for this little workshop. It should take about an hour to get through this. Okay, in this video, as mentioned, we're going to be using the Sustainable Development Goals dataset made available through the UN. The UN has set 17 goals related to sustainability in general. Some of them cover what you would think sustainability means, right? Relating to the environment. But there are other ones that are related to social issues as well. You can go on the sdgs.un.org website to find a description of them. Here is kind of a brief overview of the 17 goals. So we have life on land, protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably managing forests, combat desertification, and halt the reverse land degradation and halt biodiversity loss, right? So that one sounds very related to sustainability, right? The idea that we should be self-sustaining in the way that we use the environment, right? But there are other ones that are related to social issues. For instance, number 1, no poverty, and poverty in all its forms everywhere. That sounds very broad. All of these goals are broad, and in order to measure them, they have to measure multiple indicators, things that contribute to these. So those are listed as well. If you go onto the website, I've found this summary. It tells you all of the sub goals of each main goal and the indicators used to measure those, right? So these indicators are actually what we have data on available through the UN. And these are what we're going to visualize. Because this is a biostatistics class, we are going to focus on goal 3, good health and well-being. A lot of these data sets are medically and biologically relevant. So this is the data set that we're primarily going to be using today. You'll notice that I'm using kind of a different interface than you've used before in class with Jupyter Notebooks. This is a format known as Jupyter Lab. You have it available to you as well if you've downloaded Anaconda. Instead of clicking on Jupyter Notebook, you launch Jupyter Lab to open this interface. Okay. This is what it looks like. It kind of combines the interfaces that we saw previously. You actually have a folder directory built into the interface. So it doesn't have different windows. And it can make a lot of things easier. I preferred to use it for this workflow because I can hide cells. So this kind of gives you a nice overview of all the exercises that we're going to do today. Awesome. Okay, so in the first exercise, we're going to kind of take a look at the data and do some quick summaries. So this is kind of familiar ground, what we've already done before. So if you open this first cell, you should have access to the Goal 3 Excel spreadsheet. This needs to be in the same folder for this notebook to run. This contains all of the data concerning the Sustainable Development Goal 3 data set. Okay. It is very large, so it will take a minute for this data set to load on your computer. After that's done loading, you'll be able to kind of see what this data looks like, right? We're going to be able to see, we're going to use the data.head function to look at the first 5 rows. You'll see all the columns. Each data point is related to a goal and a sub-goal, what they've called targets. And then the data itself is measured as an indicator. This is telling us we're looking at indicator 3.1.1. You could look those up if you're interested in the accompanying file. 3.1, for instance, let's look at goal 3.1. By 2030, reduce the global maternity mortality rate to less than 70 per 100,000 live births. So that means out of 100,000 births, we want to lose 70 or less women, right? Mothers, that's the idea. Okay, these are reported by country. So you'll notice that's another one of the columns in the data set. They have world statistics, so they have averages for the entire world and continents. We're going to actually prune those. We're just going to look at the country data sets themselves. And the really important, the kernel, the real main data that's actually measured here, these are the values of each indicator, right? So this gives us the maternal mortality ratio of the entire world in 2015. In 2015, there were 225 mothers who lost their lives during childbirth per 100,000 births. So that's the average rate. So in order to interpret one of these values, you have to know what you're measuring, right? And what those units are of those. And you can find those in the given spreadsheet. Okay, one thing you may be tempted to do at the very beginning is you could run data.describe to get a summary of all those statistics. So if you do that, you'll find a count of each column, the mean value, the standard deviation. But these actually don't make a lot of sense, right? Even if we're looking at these values. Think about the things we're averaging. We're averaging maternal mortality ratios. We're averaging, what other things are we? We're averaging the under 5 mortality rate, the neonatal mortality rate all together, right? So it actually doesn't make sense. That's kind of a useless way to analyze the data. So the describe method is not particularly useful unless we can group the data first, right? If we could group the data, perhaps by, first, if we could group the data by indicator, we could get some useful information, right? So that's what we're actually going to do. The first thing we're going to do is we're going to drop the aggregated data. So we're going to drop data from the entire world and from all the continents so that we're only looking at countries as our unit of analysis. That's the first thing I'm going to do. And the next thing I'm going to do is I'm going to calculate the average over each of our indicators. Instead of averaging over the indicators, I'm going to average over the series description, which is just kind of a description of the indicator. There's a couple reasons to do that, but this makes it a little more interpretable when I look at these values, right? So this tells me, for instance, that the death rate due to road traffic injuries by sex per 100,000 of the population is about 17, right? So there's 17 deaths due to road traffic injuries per 100,000 people, right? And that's taking all of the rates of the individual countries and then giving a group, a mean of means, an average of averages, right? When you're looking at that. So that's important to be able to understand that. Awesome. You can actually look at the averages for several different values here, right? So you can take a look at those. I have a little free response question for you to answer as part of this. In the cell below, identify 2 indicators and interpret what the value of that indicator means. Comment on what you think. Is that a high value? Is that a low value? Is that what you'd expect from your experience? Give a little commentary on your interpretation of those values. One thing you could do is also reference the goal, right? There is a goal for each indicator. So you may like to take a look at that in comparison to the goals that were set. Okay. So we haven't done any data visualization yet. That's where exercise 2 comes in. we're going to use two kinds of plots that's going to give us kind of an overview of each indicator. So on the first plot, we're just going to plot each indicator. And each dot represents a value of the given indicator, right? So we're looking at goal 3.1.1, 3.1.2. Notice it's kind of crowded here, first of all. That's not very useful. So we're probably going to want to clean that up a little bit. The other thing is, look, one of these indicators dominates. And it just means that there's one indicator out there that has really high values. We want to find a way to normalize the data first, right? If we were able to normalize the data so they all have a similar range, right? They all scale between 0 and 100 or 0 and 1, it would be easier to look for trends in each given indicator. So that's what we're going to do. We're actually going to perform some averaging. The first thing we need to do is find the maximum of each indicator first, and then we need to plot that. The first thing I'm going to do is I'm going to reorganize the data into what's known as a pivot table. Notice that there's really only one column we're interested in the values of, and that's the values column, right? The value of each indicator. And I've reorganized it so I have the value of all indicators for all countries, right? This is kind of a cool way of organizing the data. Notice that the values were all in one long column, and now we've spread them out in a 2x2 matrix. It makes it a lot more interpretable for us, right? And what it's actually done, it's calculated. There were actually multiple measurements in Afghanistan because we had time varying data. It's taken the average of all of those values for us. After that, after we've organized that, we can calculate the max and normalize it by dividing each column by the max value. And now we have a much more useful graph to look at. You can see that some variables have very high values. You know, the cluster, the center of mass is at the high end, while others cluster around the low end. That's kind of interesting. You may want to ask, well, why is that? Why do some indicators have low values, some indicators have high values? And you can take a look at that if you look at actually what 3.1.1 means. It's the maternal mortality ratio. Maternal mortality ratio, that's kind of nice to know that it clusters on the low end, right? Most countries have low maternal mortality ratios. Well, there are some extreme values that are high in other countries, right? But for the most part of the world, they are low, right? With some outliers. In other words, it's a skewed distribution. It's not normally distributed, right? It has a long tail. Others skew the other way though. What about 3.1.2? That's the proportion of births attended by skilled physicians. Well, in this one, the good condition, right? You want to have a high proportion of births attended by skilled physicians. And it looks like that's the case. Most countries have skilled physician in attendance at births, right? While the outliers are the ones that are low, right? Okay. Another way of visualizing the same data is instead of coding the value of a given indicator as height, right, along the y-axis, you could encode it as color. This is creates what's known as a heat map. I kind of think this is a cool way of visualizing it. And it has some advantages over the scatter plot, right? In this case, you can kind of see similar trends. Notice that this row, the indicators that have lighter shades are indicators that have the center of mass is low on the spectrum, right? See this? They have low values. So if you have most of the color here as light, that means they have low values. Well, if you have an indicator that has very high values, that indicator has the center of mass on the upper end of the spectrum, right? So you can kind of look for trends there. Unfortunately, it's not very useful in terms of each row here represents a country, right? Each column represents a country. And because the countries are, I think they're organized alphabetically, there's not a lot of information that you can actually get from comparing columns together, right? But you get some different types of information from both, right? And I have you, as exercise 2, using the two plots above, find two trends regarding indicators and values of those indicators and describe them in words, right? So you got to do some interpretation of two indicators based off of those graphs above. Awesome. Okay, one of the disadvantages to those strip plots that we just saw is we lost a lot of information about the countries, right? In the first plot, each country is just a dot, but we don't know which country is related to which dot, right? So we've lost geographical information. This one organizes them alphabetically, right? Countries alphabetically. Still not useful. It would be nice if we could bring that geographical information back in. The problem is we don't have geographical information. We do have some. We have the name of each country. But if we wanted to plot them, say, on a map, we'd have to have the information about the country's shape, right? So in this case, we're actually going to have to merge data sets together to make that plotting possible. And we're also going to have to use a special plotting package in order to create these types of plots. Python doesn't do geographical like maps very well by default, but there is a package out there called GeoPandas that can make that possible. Now, it doesn't come by default. You actually have to install it. So to install this, what you do is you would go here to Anaconda. You would launch a command prompt here. And mine's not going to work because my Anaconda's been sitting for a day. So it's not. Normally, you want to restart Anaconda every day. Otherwise, you'll get like infinite loops like this. So anyway, you'll launch something like this eventually. It'll look like this. And after you launch that, you should be able to type in these commands to install GeoPandas on your computer. Okay. After you get that working, GeoPandas allows you to plot geographical data. The only thing is we need to access that geographical data first. Fortunately, it has geographical data built in by default. This is how you load the geographical information for countries in the world. Let's look at what that data set looks like. The important thing is first, it has the name of the individual countries, and then it has geographical information of those countries. So these represent different shapes, essentially, that make the outline of a country. The thing we need to do now is we need to combine those data sets, right? So we have this data set that has names of countries, and if you look at our other data set, it also has names of countries too. What did we call those? Geo area name. So we need to merge these together by telling Python that this column is the same as the geo area name column in our original data set. Now, there are some problems, though. There are different nomenclatures, right? So in the first data set, they don't use abbreviations. And in our new data set here, they do. So they abbreviate Solomon Islands like this. So this is one of the most annoying parts of data science in general, is you'll have data sets that aren't compatible. So you'll have to manually go through and make sure that they align, right? So every time I see Solomon Islands abbreviated, I'll have to go and spell it out like this. This can be done manually, and I did it. I actually haven't corrected the whole data set. I'm pretty sure I've missed some. It's always a possibility. I didn't have enough time to go through the entire data set. Very arduous task, but a lot of analysis, a lot of statistics comes down to something really annoying, mundane, like going and changing names of cells like this. There are more advanced tools that can do this automatically, but they are built on some assumptions and they require some special software. So we're not going to do that right now. I'm just going to run this manual data cleaning thing that I typed up myself. After that's done, you can merge the data sets. So I'm going to take both our world geographical data and our indicator data and make them into one data set. Okay. And after doing a little bit of cleaning up, I have to actually do some averages over a year again. I do that here for you again. We can create a plot of any indicator we'd like, right? So in this case, if you run this cell, it creates a plot of indicator 3.9.3. Notice it doesn't show up immediately. It actually creates a HTML file for you. So here's our map. So this is a map. Notice some of the countries are missing, and it's not because the data wasn't available. It's probably because I didn't have names were incorrect, right? They didn't map correctly. So we're missing data for Turkey and Iran. But you can already see some geographical trends, right? You can do some interpretation here. This is the mortality rate due to unintentional poisoning. We have high values of 5.6 per 100,000, I think, and 0 per 100,000. So you can see the countries that have the highest rate of unintentional poisoning is, I think it's Somalia. And the lowest here with, like 0, almost all of North America and South America and most of Western Europe, but perhaps not Eastern Europe. Okay. So you can look for trends like this. You'll notice a lot of trends do tend to stick out, right? For most of our data set, unfortunately, there's regions of the world that don't have the same levels of health that we enjoy here in the United States. And you'll see that over and over again in a lot of these analyses, right? There's a lot of room for improvement here in this case, Asia, as well as Africa, and maybe Eastern Europe as well, right? So that is, you can verify that. I actually ask you to do this for other indicators, right? And you can do that. There's 3 things you have to change. The first thing you do is you need to change the indicator you're interested in. So go on that list and find one you'd like to create a plot of. You're going to need to change the title manually, the legend. And then you'll need to make sure that you change the name of the file that it saves to so you don't overwrite existing files. So that's how you do that. I ask you to create your own plot and then interpret that. I'd like you to turn in the HTML file that you create as well for this. Okay, the next one, plot of plots, looking for trends. So in this case, what if we wanted to look at one country or maybe a handful of countries, and we actually wanted to look at trends over time? So far, we've thrown away the time data, we've averaged it out, but there are actually changes. You can see that some countries may be improving or opposite of improving, they may be backsliding in certain indicators. And maybe we want to create a quick visualization of multiple indicators to see if we can see some of those trends. And that's what we're going to do here. I've created a function that does this for you. Let's try this really quick. Now, the function runs like this. You type in the names of the countries that you want to plot, and you can also change the colors of the lines for those as well. And if we run that, let's see what happens. Here are our indicators. So I have sub-goals. Each plot here, I was only able to represent 9 sub-goals in this one. And then there's multiple indicators for each sub-goal, right? So this has 3.1.1 and 3.1.2. And you'll see some trends. See if there's any that are interesting. Are there any that are decreasing or increasing significantly? It looks like, for instance, the black line here is increasing for, what does black represent? The United States. So we have an increasing rate. These are all normalized, by the way, so that they show up on the same kind of, they're all normalized between 0 and 1, I think. 3.5.1. So black is increasing in blue. So Mexico is decreasing in whatever 3.5.1 is. So in this case, 3.5.1, coverage of treatment interventions for substance use disorders. For substance use disorders, interesting. So America has been increasing in that, while Mexico has been decreasing. Interesting. Okay, so you can try this out. I'd like you to try some different countries, see if you can see any different trends. And I also want you to do a different indicator. You can actually plot more than 3. You can plot as many as you want. You just need to provide a color. You can, there is a list of named colors. I think I showed these in class. You can Google matplotlib named colors. Try some different colors out. I did have an interactive way of doing this. So instead of writing a function, you could actually use drop-down menus here, but I broke it somehow and I forget how to fix it all. But this is the code for that. That's not going to work right now, so don't worry about that. You don't have to run this one. I do want you to try to pick 2 trends showing differences between countries. Maybe be selective in the countries you try to pick, right? Maybe pick some kind of theme. Maybe you want to look at countries from the same continent, right? Maybe you want to, or maybe you want to compare countries from different continents. Maybe you want to compare large and small countries, or any kind of combination of things like that that you might think is an interesting set to compare. Okay, the final exercise, exercise 5. Just like we merged data in the previous example when we needed geographical information, we're now going to look at data sets. We're going to look at the data and we're going to try to look for trends within the variables themselves, right? Is there some kind of relationship, for instance, between maternal mortality rates and infant mortality rates between countries, right? So we're going to plot indicators against each other, But we may also want to include other data sets, other quantitative data sets that might prove interesting when plotting trends. For instance, maybe we want to plot an indicator against population, right? Population isn't one of our indicators, so we're actually going to have to grab that from somewhere else if we think that population may influence one of these indicators, right? So with that, the first thing we're going to do is do a visual inspection of our data itself. This is a really kind of cool function. It's called scatter matrix. And it's a way of previewing your data first to see if there's any trends between variables. It takes a long time to run because it's actually plotting every single indicator against every single indicator, right? So we're going to have a plot of 44 by 44 plots. Now that's a lot of data analysis going on. It's going to be really big. It's probably going to be hard to read too, because each plot will be fairly small. But you'll be able to quickly scan to see if there's any interesting relationships between variables, right? Is there a linear relationship? Does one indicator affect or not affect a variable at all? Is the data noisy? Or can one variable predict another very well, right? Do they fall almost on a straight line? So we're going to see that here shortly. Loading, loading, loading. So here we are. Here's our plot of plots. And you might see some interesting trends. Notice this trend, for instance. This one almost looks, they almost fall all along a straight line, right? Some of them are more noisy, like these don't look like they're related at all, right? Some look slightly related. It looks like this one has a downward trend, but it's very noisy, right? So try picking one, right? So you can look at the row and column. And this will give you the indicator that you'd like to try looking at further later, right? So we could look at 9 against 10, for instance, right? That might be an interesting one to look at. But before we do that, before we plot trends against each other, I thought we would plot one against population. Now I've included some population data for you. And just like the previous analysis, we're going to have to clean up the data first so that they use similar nomenclatures. And then we're going to have to merge the data sets. And that's what I do here. I merge them for you. Following that, I have created a little tool for you to plot indicators against population. So here's the population of the countries from low to high. High here is probably China and India. Low is probably really small countries like Liechtenstein or Monaco, right? Notice that I put population on a log scale. Notice it's, maybe you've seen log scales before. Instead of plotting the x values as x, we plotted them as log of x. What that does, it has the effect of scrunching down that axis. If you plotted China by default, it would be way out in left field, it'd be off the screen. And so I plotted the log to compress the data a little bit. That makes it easier to see and to see trends. Notice I've also included more variables. Instead of just plotting a normal XY plot, I've also taken advantage of marker size as well as color, right? This is kind of a cool analysis. Color represents the continent of each country, right? So that way you can kind of visually group continents. It's a better way of quickly seeing trends, geographical trends within this data set. And I've also scaled each dot to the GDP, or how much money each economy of that country produces, right? So if you have large dots, you have large economies. And if you have small dots, you have small economies, right? So it's small. It kind of confounds some factors, though. You could have, countries that are poor, but you could also have small countries. And both of those would be reasons to have small dots, right? It kind of, both of those are built into that dot size, okay? But now I've actually built in 4 variables into a single chart: population, the death rate in this case by traffic injuries, the economy, size of the economy, the GDP, and the continent. 4 variables in a single plot. That's really powerful, okay? So in this case, let's take a look at it. What are some things you notice about this one? I noticed, for instance, that the green dots all tend to be up here. There are some that are lower, but they all tend to be up here. They're on the higher end, right? So Africa in this case has high death rates due to road traffic injuries relative to other countries. While Europe, the yellow dots, tend to have low ones. Asia is kind of in the middle, right? And then South America is kind of in the middle. What about North America? We're kind of scattered there too. It looks like Europe has some of the lowest. Now, is there any relationship between death rate due to road traffic injuries, the rates of road traffic injuries and population? And can you fit it to a line that's decreasing or increasing? Not really. It looks kind of a noisy cloud, right? So maybe you want to look at a different indicator, right? So you could come up here. Let's try changing it to 4 and see what happens. All you need to do to change this plot, it'll automatically update for you. You just need to change the indicator number here. So here we're looking at another indicator, under 5 mortality rate. So see if you can find any interesting trends. Maybe you can find one that's related to population. Maybe you can't. So play with that. And I want you to comment on one of these, right? Try changing the indicator, find a relationship you think is interesting. That's one thing I want you to do. The next thing I want you to do is play around with plotting indicators against themselves, right? So in this case, I have plotted 20 against 28, 20 against 28. So that is death rate due to road traffic injuries plotted against age standardized mortality rate attributed to household and ambient air pollution, right? So we're essentially looking at death rates due to accidents, death rates due to air pollution. It's kind of interesting. This one, I initially found this by looking at my chart, right? You could actually see if there's any that are semi-related by looking if they kind of fit along a straight line. This one was noisy. They didn't fall on a straight line, but they do look like they're positively correlated, right? So that means that countries that have high road traffic accidents, injuries due to getting in car accidents, that means you probably also have a lot of deaths due to air pollution, right? That's kind of interesting. So see if you can find any interesting trends here, make a cool plot and comment on it. And after you do all those, that will be enough to get credit for this activity, right? So you just need to run through the notebook yourself, find some interesting trends, comment on those trends, submit your Jupyter notebook, as well as your HTML file that you created for the geographic data set. So with that, I'll wrap this video up. And yeah, hopefully this was an informative activity.